Hello everybody, this is your revision video that is about distillation. So distillation is one of the separation techniques that you will have been learning about in the 7E unit called separating mixtures. So this unit is all about how you can use different separation techniques in order to separate different types of mixtures. So this is used to separate a solvent from a solution. So before we do anything else, we need to make sure that we know what these words mean. So have a look again at this keyword reminder box that I've got. A solvent is the thing that is used to dissolve a solute. So what do I mean by a solute? Next one down. This is the thing that dissolves in a solvent. So if I had a mixture here of salt and water, for example, or it could be ink and water or something like that. So let's stick with ink and water. It's a better example for this. The ink will dissolve in the water. Okay, so just like on the previous slide, so if I go back and I said that if you were to put these into the water, they're going to dissolve in the water and the water is going to become all of these different colours mixed together. That would produce a solution, which I'll come back to. So the solvent is the water, because this is the thing that does the dissolving. The solute is the thing that dissolves in the solvent. So in this case, it would be the ink. The solution is the resulting mixture when the solute has dissolved in the solvent. Okay, so this is our distillation's set up, which I'm going to come back to because I've got a slightly more detailed one on a couple of slides time. But we would basically put the solution that we've made into this round bottom flask that we've got, and we will perform the distillation. So I'm not going to go into loads of detail on how that works just now because that's on a couple of slides, but this is just so that you can look at the keywords and you can look at the apparatus setup. So moving on a little bit, on the next slide I've just got a real life setup of this so that you can see what it actually looks like. So as you can see, we've got this solution, as we said, so this could be inky water, as I said, in a round bottom flask. Sometimes you've got a thermometer at the top so you can see the temperature just here at the top here. It's got a clamp and a clamp stand, so it's fixed in place. We've got a condenser that's always attached to a water supply, and that's just to cool down whatever it is that you've got in here. And then you've got a conical flask again, a flask that looks like a cone, just at the bottom. So I've just at the top, just in your own time, you can read through some of the safety precautions that you need to take when doing this. So let's look at the apparatus in a little bit more detail. So this is a slide that you will have seen in lesson time. If you want to, you can pause the video, you can copy that equipment down, or the apparatus down, sorry, and you can label it. That's absolutely fine. I'm not going to spend ages doing that. I'm just going to skip to the next slide and show you where the labels should be. So I'll just put them all on and then we'll go through them one at a time. So what we've got is, first of all, a Bunsen burner at the bottom. Okay, so we'll actually just focus on this whole left-hand side of the diagram to start with. We've got the ink solution that's going to be in this round bottom flask. So the round bottom flask is named in exactly the same way as the conical flask. The conical flask was named conical flask because it looks like a cone. The round bottom flask is named this because it's got a round bottom. Okay, the bottom of the flask is round and that's it. And it's got an ink solution in it. We've also got the tripod, again, just similar to before, and a gauze. So that's that dotted line, and that's just to allow the round bottom flask to be put on top of the tripod. And then we've got the Bunsen burner. Okay, so again, that is an upwards pointing arrow with heat. That is because we are going to have to heat this solution in order to separate it, which I'll come back to in a minute. We've also got the thermometer, as I said, that's labelled, and that is just to make sure that we know the temperature of the air as it's going into the condenser. Okay, so what we do during this experiment is we heat up the solution, and because we've got two different substances in here, they will have different boiling points. Okay, so what that means is if you've got water in here, the water, as we said on the previous slide, will turn into a gas at 100 degrees. The ink will have a slightly higher boiling point. So what that means is if we heat this up to, say, 110 degrees, for example, the water will evaporate so it will turn into a gas, but the ink will remain in this round bottom flask. So that's the first step. It's separated in a really similar way to the evaporation technique that we talked about before. Water will evaporate, the ink will remain behind because it's not hot enough for the ink to turn into a gas. Okay? When it gets up to here, the thermometer is going to check the temperature, and the water that's now a gas, so steam, is going to start travelling down the arm of this condenser. Okay, so just where the mouse is at the moment, you can see that's where the water is going to start travelling. However, this condenser is really, so you can see it's labeled condenser there. It's a really clever piece of apparatus because it's got water surrounding it. So what you can think of it as is it's a little tube that's then surrounded by another tube that's got water flowing through it. And this water is really cold. So it comes from the cold tap. So if you've just heated the water up so it turns into a gas, if it collects in here, it's then surrounded by cold water, which is going to do the opposite thing. It's going to make it go back into a liquid from a gas, because that's what happens. If you cool steam down, it's going to turn back into liquid water. Okay, so that is where in this beaker that we've got at the bottom, this liquid water, again, this pure water now, because we've removed the ink from over here, is then going to be collected in this beaker. Really important that you know the correct way around these labels go. So the water goes in at the bottom and out at the top. Okay, so please make sure that you've got all of those labels. If you did have a go at doing that, make sure you've got them all labelled in the correct places. So let's go on to this in a bit more detail in terms of what's going on. Sorry, let's just go on to the next slide. So as we've said, we've got evaporation happening in the first instance. And then when it travels down the arm of this condenser, we've got condensation or condensing happening. Okay, so we've got two changes of state happening in order for this pure water to be collected. The water evaporates, turns into a gas, goes into the condenser and condenses and turns back into a liquid. The result is that you'll have pure water in this beaker and you will have pure ink in this round bottom flask. Okay. So this is just giving you a little bit more information. So we've got the inky water. At this point, the substance with the lowest boiling point evaporates. The vapour will rise. So in the example that I've given you, it's the water that's got the lower boiling point, and therefore it will boil at a lower temperature. So you don't need to heat it to be as hot. So it could be inky water, it could be salty water, whatever. In both of these cases, it's the water that will evaporate. And then in the condenser, it will cool that vapor or that gas down so it condenses back into a liquid. Okay. So this is just showing you a little bit more information. Again, you will have seen this in lessons. So everything that's on here, except from this box in the top right-hand corner and these three boxes with the particles, is what was on the previous slide. The extra particle diagrams that I've got are just to give you a bit more information. So it's just saying on here, draw what the particles would look like at points A, B, and C. Okay, so this is point A, this is point B, and this is point C. So at point A, what you can see is we've got a liquid. It must be a liquid because we've got all of the particles are touching, but they are randomly arranged. Okay, so that makes it a liquid. You can also see that we've got particles that are two different colours, and that means it's a mixture. So in this case, we've got the ink and the water. The blue particles being the water particles, and the yellow particles being the ink particles. We've said that we heat this up so that the liquid turns into a gas. And now at point B, we have got pure water, but as a gas. So you can see this second particle diagram. We know that it's pure because now we only have these blue particles rather than having the yellow ones in as well. And we know it's a gas because they're still randomly arranged, but now they're not touching anymore, and that makes it a gas. Okay? We have then said that this condensation happens, which means that it goes into this cooling period where it turns from a gas back into a liquid, which leads us on to this third particle diagram where it's a liquid again because they're all touching and they're randomly arranged, but this time it's pure water because we have now only got the blue water particles in comparison to the mixture of the water and the ink at point A. Okay? So the final thing that I've got is just a little bit of a practice test question. So how might this look in an actual test for you? Again, you should have seen this in lessons, but I'm just going to go through it dead quickly. I'll read out the question. I'll then move on to the answer straight away, but you can obviously pause the video and have a little bit of a chance to answer that first. But this is the question. So a student set up the apparatus on the right to obtain pure water from seawater by distillation. So what that means is we have got salty water and we are trying to separate the salt and the water using this setup that we've got. Explain how the apparatus could be used to produce pure water from seawater. Okay, there is an extension there as well that you can have a little bit of a look at. So pause the video now if you want to and have a go at the question. I am going to move on now to just put the answer on the screen straight away. Okay, so here we go. So I've got the answers to the first part and then I've got the extension at the bottom there as well. So the points that you need to say, the water will boil. Okay, so you've got a mixture of salt and water. If you apply heat using a Bunsen burner, the water is going to boil and evaporate. This will form steam or water vapor or water as a gas. Okay, that will form here and it will leave the salt behind in the conical flask. The reason it leaves the salt behind is because it's not hot enough for the salt to actually turn into a gas. Okay. The steam will then go into the condenser. So this is normally surrounded by water. It's more effective if it's surrounded by water, but it doesn't have to be. It'll still cool down. And the steam will condense on the tube or in the tube. So remember that means it turns back into a liquid and that will then collect in this case, the boiling tube, or it could be a beaker or it could be a conical flask or whatever. But it will form pure water. So it will have the salt removed down on the right-hand side. Okay. The extension, explain how the apparatus could be improved to increase the amount of pure water collected from the same volume of seawater. Well, you would surround this condenser with water or with ice, or you could even wrap it in a cold cloth, and that would cause this condensation to happen more quickly and more effectively. Okay. So, that's just what that says. So pause the video if needs be, and you can make sure that you've got that answer down properly. But in terms of revision of distillation, that is the end of this revision video. So I really hope it's been helpful. Thank you very much.